Welcome everybody to Defender Fridays. As usual, kind of the quick pitch here is we get to talk to all kinds of interesting people on the defensive side of the industry, all kinds of different aspects, and we want to have those discussions with more people, expose different people to these. And so the spin here is this is not like slides, it's just a discussion. Feel free to jump into the discussion. We're just here to discover and think about new things. So today we've got Farshad with us. How's it going?
Good. Nice to meet everybody.
Awesome. Do you want to maybe start with a quick introduction about yourself?
Introductions. Yeah, sure. I'm based out of Vancouver. I've been doing IT and software and everything security for quite a while. I started my journey back in the late 90s as a software engineer. I built software for about, I don't know, 14, 15 years. Also spent quite a bit of time building infrastructure, network systems, data centers, all that stuff. Equal part experience on both sides. Pivoted into full-time security. Well, I've been teaching network security since 2002. So quite a while. I don't know how many years that is, 24. And pivoted into full-time practicing security in 2008. I joined HSBC Global Bank and helped them set up an application security team, managed and scaled that team globally for 5 years, was the head of IT security for the Canadian division for a year, and then built an enterprise security architecture team for them and migrated all the stuff into AWS and Azure and GCP in a secure way. And then I left because they didn't pay me well enough and decided to start my own company. And here we are 7 or 8 years later. It's been quite a journey.
Awesome. I'm sure 2008 AppSec must have, there's a big change to where it's at now, right?
Huge changes, huge. And we went through, I'm grateful for the experience because I joined right at the end of the waterfall era, because at the time we were building software waterfall methodologies. And then within the first couple of years, they went to Agile. So no one was doing security with Agile. So we had to figure that out. And then by 2014, the bank was like, hey, we're doing DevOps and microservices and all that. We had to figure out how security fits into that. So we were always at the forefront of these changes. But I'm grateful because we got to learn. They had a lot of budget, a lot of scale. So I got to learn how to do it at that scale. And now we're helping companies that are small, small, medium enterprises that don't have that kind of budget and that kind of resources. So we're bringing what we learned and trying to help, smaller companies adopt those best practices.
Very cool, very cool. And so I'm glad that so you wanted to talk about AppSec, which I'm really happy about because I feel like it's one of those things that has existed for a long time. I'm sure it's changed quite a bit, as you just mentioned. But I don't know, maybe it's my world, but I feel like these days we don't talk quite as much about it. What's the what's the current state of AppSec?
Oh my God, current state of security. It's chaotic. AI has made everything just so much more chaotic. I mean, you made a good point, right? Like AppSec has usually been the abandoned child in cybersecurity. And previously, for good reason, not many companies back in the day were exposing their APIs externally. The attack surface was small. Companies had some internal apps. The firewall gated everything. It was good enough. So most of the focus was on infrastructure security, like, pen test, all that kind of stuff. Pen test your infrastructure, make sure it's good. Apps are inside, we'll be okay, right? And then came the early 2010s where it was like, well, inside and outside are the same. That's when the concept of zero trust came out. I remember in 2010, we had a huge meeting. They're like, oh, we got to implement zero trust across everything. We got to re-architect all of our systems. We're implementing service-oriented architectures. That's when it started to begin. They started to expose APIs externally, attack surface increased, zero, it was like inside and outside are all the same. And so the way of looking at applications, it required a lot more stringent, scrutiny and that kind of stuff. But unfortunately, the practices haven't really kept up. We're still applying pen testing practices that were designed for testing infrastructure to applications, and we think it's okay. It's not okay. Like most customers come to us and they're like, I want a pen test. They don't even understand what that means, that they don't even understand that pen testing doesn't really find your real security application. It doesn't find real issues in software. Because by definition, pen testing was designed so that you go find known CVEs and try to exploit them. Whereas the software you built, half of it, or maybe more than half of it, is brand new code. There are no published CVEs. So even by definition, the pen testing methodology doesn't really work. So you need to actually do code reviews. You need to design review it. You need to threat model it. Those are all the things that OWASP has said in their testing guide, but no one pays attention. No one even reads that stuff. They just, if you read the guide, they say, oh, pen testing is the least effective method to test your software. But, every compliance requirement, SOC 2, PCI, they just say, hey, do a pen test, right? No one has even considered those things. So we have a huge problem in the application security industry. And now AI is making it even more interesting and challenging for all of us. So that's my rant.
It's interesting to hear the pen test side from the AppSec side because uh I'm not like I've never really been on the AppSec side, but I can relate to pen test kind of had its really high point where it was just like super sexy. Everybody kind of wanted to be a pen tester, right? But to your point, okay, we could easily spend an hour talking about the efficacy of pen testing, um, and the reality is good, like good pen testing, like really customized, could find some of these, but nobody wants to do that because I just correct me if I'm wrong, but I suspect nobody wants to really pay for that depth of like I'm not just going to run Nessa scan on the thing, right?
Exactly. They come to us and they're like, "Oh, I want to, pay $5,000 and I want this pen tested. Why can't you do it like the attackers do, right?" Like, and because I usually tell them, "Hey, if you don't want to spend a lot of money, give us the source code." OWASP says that and say, "Hey, OWASP has three levels of testing. They have level one, two, and three. Two and three are white box. They clearly say if you're doing two and three, if your application is considered to be that important, level three is like, hey, you're handling patient data, medical records. It's a payment gateway, large value transactions. You're automatically at level three. There's 280 test cases you got to do, and it's got to be white box. Whereas level one, it's about 150 test cases. They say you could do it black box, but then they say, and this is the important part, you know, give the source code to the tester because when an attacker is attacking you, they may have unlimited time. Most companies aren't doing the logging and monitoring properly, so the guy can hack at you for a while, and eventually they'll get in. But if you bring us in for a week, we're not. It's not a level playing field. You want me to do a black box in 1 week, and you want the same result as the attacker, he might have a year to do it. So I tell them, if you want to do it in 1 week, give me the source code, give me all the design, do it white box. We could get you something as useful as what the attacker gets, but that concept is quite lost to a lot of people out there.
So what what becomes the difference between the white box versus static analysis, or is there a big overlap? Like to me, it feels like they're almost the same thing.
I would say they're the same. Yeah, I would say once you get insider information, like having the source code or design information, that's a white box. And I would say.
Got it. Got it. And am I correct again? Like just assumption on my part that uh, AI must have done quite a bit around the static analysis side.
So they're doing both. So I'm testing out a platform. I'm not plugging in for anyone, but Infiltrate IQ is a Canadian company out of the East Coast. We're testing it out. They're doing a primarily no source code. They just basically you give an IP address, you give it a little bit of context. Hey, this is an application that does this, 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 and some information, and they go and run all the dynamic tools. They'll run burp and a bunch of other things under the hood, and they do something like a pen tester would do. Expo is another platform. Expo is out of the Silicon Valley. It's making a lot of splash in the industry right now. All those tools try to do it just by interacting with the application, understanding it. I mean, some of the challenges normally are understanding the mapping of it, right? Like if it's how do you map it? So humans normally go and click on every feature, put a proxy in the middle, and then they're able to capture all the endpoints and map the application and be able to then go and put payloads into all of it. That's usually one challenge. It's often resolved if you have Swagger or REST API or introspection point if it's a GraphQL API. So that discovery is the difficult part, but these AI tools claim to have figured it out, that they're able to hit every endpoint, map the application, and then be able to dynamically go and pen test it. So, usually the challenge with automation for pen testing has been access control because you need context, right? Like the tool doesn't really know you have four roles, what they're supposed to do, whether that's a problem or not. That's been the thing that humans usually do in app pen testing is the access control. And then also things like deserialization problems. Those are not easy to catch through automation. So typically the tools have been an enabler for the pen tester. And then the pen tester goes and digs deep into those kinds of access control, deserialization, those issues. but some of these AI pen testing tools claim to be able to do that given the right context. So we're testing them out to see if we could use them as enablers, not to replace it, because I think we could use those tools and then layer our expertise to find even more things, but that's to be determined.
Right. Yeah, it feels like it would be particularly good with the white box approach, just for the ability to kind of trace through code that, yes, a human could do it, but when it can have the equivalent of 100 humans kind of like do it on the side, like that's not the interesting part anyway, and kind of like narrow down, like you're saying, this mapping of the interactions between the subsystems, right?
Yeah, you make an interesting point, Maxime. Like maybe let's take the conversation into the like pen testing versus source code, static code review, right? What's more valuable? I think in application, it's funny, when I started the company, one of the first AppSec consultants I hired, he'd come from the background where they focused on the code review more than the pen testing. And our company had focused more on the pen testing, less on code review. So when he joined us, he was like, I can find SQL injection, all kinds of better stuff through the code review. And I was like, no, it's better to pen test it. But now I've realized actually he was right. You can find a lot of the AppSec issues better by looking at the code rather than pen testing it, because you can go through the source code and do source to sink analysis, figure out, hey, if I put some tainted input here, what are all the different functions it hits? Now, what it doesn't do when you're doing static analysis, you're not running the application. So you don't actually see, well, you can see the function call statically, but you don't know if that happens or not. So there's still value by validating things through dynamic testing, but my opinion has changed. I think now, if you ask me, I'd say, yeah, source code analysis gives you better results than pen testing for applications.
In particularly, I would think because of AI nowadays, right? Because like, can AI drive tools that probe, like, doing pen testing? For sure it can, but that's going to be slow. It's like integration tests versus unit tests, right? Whereas understanding the flow of language, like, that's the number one use case of all the AI tools. They're, the Claude codes of this world. So I would assume it'd be great at it.
Exactly. And we've been experimenting with that on our side, and I know other companies too. SemGraph, which you may have heard of, they're one of the best static analysis tools, but they've used, their traditional, they just rules and they just do rule matching. And they do their commercial edition. It does do call flow analysis or taint analysis. It will look at an entire code base across all the different source files, and it will trace that call flow, but that it's lacking context. So recently they've added their AI assistant, which does that. We've also built one in conjunction with Simon Fraser University. We did a research project, and we've built a service where you can take the results of a SAS tool. So you run your favorite static analysis tool, and it takes those results, and then it also creates the call tree. So whether the tool does it or not, many free static analysis tools don't do that call flow analysis. So what we do is we don't care. We just say, hey, the tool reported some issues. We will go create our own call tree. And then we also do contextual analysis. Like, we'll look at the CWEs that were flagged with that issue, and we go, hey, does it really make sense given the context? What are the related CWEs? So we understand as much context about the CWE and the code base as possible. And then we tell you, hey, this issue that your static analysis tool provided, it's a real issue or it's not. So we reduce false positives down. Like, normally that's done by humans, right? Like, traditionally, the tester runs their favorite SAS tool, and they sit there manually triaging all of those, looking at the code base, adding context. So this AI service that we make automates all of that essentially.
Very cool. Very cool. Is that sort of like the cutting edge nowadays for AppSec?
Yeah, pretty much. So that's where things are going, is contextual analysis. Because without context, right, you're spending a lot of time doing that, like figuring out, okay, well, found a vulnerability. Is it really an issue I should worry about, or is there other mitigating controls elsewhere? So the other problem with the industry is that they focus on severity rather than risk. So you run your tool, Nessus or whatever tool that you run, you could run a static analysis tool, gives you all these CVEs, right? But then again, goes back into the context problem. It doesn't know about the context. So for example, your tool might find a SQL injection, but you're like, hey, in this SQL database, I don't have any data that's high impact. I have a bunch of data that's low impact. So the risk is impact and likelihood. You got to figure out, what is the threat scenario? Is that SQL injection possible by itself? Or are there other vulnerabilities that need to be combined? Like, do I need to break the authentication first? is that vulnerability present before I can reach this endpoint to do the SQL injection. Once you combine those vulnerabilities, you now have a attack pathway or threat scenario. You got to determine the likelihood and the impact. Now you have a risk. Then you got to figure out based on risk what to address, right? Severities don't tell you that. So the industry, basically the tools give you severity. You still have time. You have to spend time to figure out the likelihood, whether this chains up. And most companies don't do that. They don't do the threat modeling. They do some contextual analysis, decide whether it's false positive or not. But to do it properly, that's what has to be done is threat modeling, risk assessment, and then addressing things that have high risk and ignoring all the other issues, essentially.
Yeah, I wonder. I wonder if it's going to happen. I remember sort of like in the 2010s, there was a point where we kind of went. I'm thinking about vulnerabilities, like exploits, right? We went from a world where like, hey, I could get one exploit that kind of like gave me access to the thing, and then most languages started fixing things like Stack Overflows, and like those became rare and rare and rare. And then the game started to be, well, I've got these 20 tiny bugs that I found, and if I chain them in this really complex way, I can actually get to the end goal. And so it almost feels like what you're describing is like we're kind of getting into that phase of like, yes, I found this, potentially this really low, impact vulnerability, but if I chain contextually all of those together, then I can get into that.
Exactly, and that's what needs to be done. But it's time consuming, right? Like where I worked at HSBC, we would do that manually, but it was very time consuming to get together, put everything on the table, threat model it. It's easier to just like, hey, I ran this. Here's the vulnerabilities with severity. You go figure out the context. You figure it out. But that's not so great for the consumer. They just want to know what to fix and how to prioritize them. But to do that properly, that threat modeling exercise needs to happen. You need to do a risk assessment, and that needs to look at maybe like you said, maybe a low severity vulnerability. It can be a high risk issue when combined with the other vulnerabilities that you may have in your system. So that is often what's not done. It's interesting because back in 2021, the US put out an executive order, and it was that software supply chain executive order that sort of hit the world with SBOM. And all of a sudden, every SBOM company was like, on the news, and lots of companies were trying to do SBOM and all that stuff. But one thing they did in that executive order, they said, if you're building software and you want to sell to the government, you have to do threat modeling, code reviews, vulnerability management, pen testing, all the things that I've been mentioning, not just, hey, I did a pen test, that's enough. And it has to take a risk-based approach. And that was really great because Gartner right away, they updated in 2022, they updated a lot of things. They said, hey, you know what? The AppSec industry needs to go risk-based. This whole way that we're dealing with things in a vulnerability, individual vulnerabilities, that is not working. And then there was a whole new category of products that came out, of course. We had prior to that, there was these category of tools they called ASOC, Application Security Orchestration Correlation. There were a bunch of companies that were making these tools. They essentially ran different scanners, static, analysis, dynamic, and they aggregated and combined the issue, but they still showed vulnerabilities. Right after that, ASOC got updated to ASPM. So you guys may have heard of ASPM or CSPM, that kind of thing. The difference was that they changed it from application security orchestration to application security posture management, adding that risk. They're saying, hey, you got to take context into account. You got to like take risk into account. And it's not enough. You got to chain up. It's not enough to aggregate the vulnerabilities. You got to figure out risks based on those vulnerabilities. So now the industry is starting to go in that direction, which I've been shouting for a while. Like we've been doing when we deliver services, we take all these approaches. That's exactly what we do, but we do it manually, and it's really time consuming. So we're also trying to build AI-based tools that can automate some of this threat modeling. And there are tools right now. There's Stride GPT. It's an open source AI threat modeler, but a lot of these tools are still focusing on the old school threat modeling where you're threat modeling based on data flow diagrams and doing it at the architecture level. But what you need to do is you also need to do it at the functional level, at the user story. You need to also run your tools and threat model based on the vulnerabilities that were identified from the tools and everything else. That's not often addressed by traditional methods of threat modeling that are focusing on, the big components and the architecture and data flow. So that's another gap in the industry at the moment.
That's very cool. I like the way you told kind of like the storied evolution of that. It makes me very happy because there's not that many stories in security that kind of show this like, hey, let's take a moment and reflect about how we're structuring, how we think about risk and all of that. So to kind of hear it that way is really super cool. And yeah,
it's been an interesting but frustrating journey, because we're like, the AppSec is the less understood child, and when it comes to cybersecurity, the common question I get, people come to me, they're like, hey, I'm trying to go to cybersecurity, what do I do? I'm like, well, what part of cybersecurity? There's infrastructure security, app security, GRC, SecOps. There's so many different domains. AppSec is one of them. But most people, they kind of lump everything into this general bucket of cybersecurity, and they think it's all the same. But there's a lot of nuances, and AppSec is closer to the software engineering practices than it is to anything else. So it's more relatable. And the other challenge I find is that there are not enough ex-software engineers who pivot into AppSec. A lot of people that go to cybersecurity, including AppSec, they often have infrastructure backgrounds or network security backgrounds. And this has been kind of my mission. I'm like, hey, if you're a software developer, this is an easy pivot for you. It's just an extension of, hey, you built software, you built REST APIs and GraphQL, and you wrote SQL code. It's so easy for me to teach you SQL injection because you already know how to build this. But for some reason, not enough software people pivot into AppSec. And that's what we really need, is we need more of those people that build software that have reached a certain maturity level in their careers to come jump over ship and start helping the rest of us secure that software. So that's something I usually shout about quite loudly out there.
Nice, nice, nice. So is, if you look forward as like the next kind of big challenges that need to be resolved, I feel like, saying having more good people, help do the job is probably common to the entire cybersecurity industry.
Yeah.
Is there anything else that you're kind of seeing on the horizon where you're thinking, oh, there's a big, there's a dragon there that we're going to have to solve?
It's funny that you're right. The people's problem is always across the cybersecurity. For AppSec, OWASP says that for every one AppSec engineer, there are 120 developers. So the ratio is quite out of whack. And really, the solution is not solvable by adding more people, just across the industry. I think we need to harness tools to be able to scale better. We need to find different ways. I remember at the bank, when we went into the whole DevOps way of building things, they said, hey, we have hundreds of these DevOps teams. Can we put an AppSec person in each of them? I'm like, well, look, we only have less than 20 AppSec people. There's just no way. And that's where the concept of security champions came out, right? Like security champions came out in that early 2010s. It was like, hey, how do we address the scaling problem in AppSec? Well, let's make a developer, call them security champion, and enable that person so they understand the low-hanging fruit. And following the 80-20 rule, 80% of problems are low-hanging issues, right? So if we have a federated model that there's one AppSec supporting a dozen security champions, they can federate the knowledge. The low-hanging fruit gets addressed at the bottom level. The idea of DevSecOps came out, which is also a very poorly understood term. If you go to devsecops.org, the official site, they describe it as, it's not a person, it's a cultural transformation. It's about that DevOps team just building secure software. And, some companies go, hey, I hired a guy, he's going to come and automate my infrastructure. That's not really DevSecOps. DevSecOps is like, is your team able to develop and operate security by having the right tools in CI/CD, having scanners and gates in the process, having training, having a security champions program. All those things result in that DevOps team building things in a secure manner and elevating to DevSecOps, right? But again, that's another challenge in the industry. What I see happening is that I see a lot of our, AppSec folks just, using AI. Like every company out there, from SaaS static analysis tools to software composition, dynamic tools, they're all adding AI to it. And that's going to make the job of AppSec folks a lot easier. Even for pen testers, I've seen really cool AI pen testing platforms one of our partners is building. So the tools that folks are using are going to change. Even Burp itself has added an AI feature where it makes finding and reporting things a lot easier. So I think we'll still require AppSec people, but what they do will be different, is how I see it, essentially.
It's super interesting. I thought you were going to go the exact other way. I thought you were going to say, with the advance of the AI tools, there are so many different people that are going to start building software that don't know what they're doing, and it's going to be a nightmare. But I feel more and more seeing kind of the curve for software development through AI, that it's the other way around, which I think is what you were saying, where yes, more and more people might start building software, but I think the AI is going to get better and better at just doing that safely. And so you may not have a DevSecOps team, the ability to have kind of this maturity, but maybe the AI is going to, be the one backing that for you.
It will happen. Yeah. So right now, your point is valid, right? So I mean, the digital transformation and the rate at which we built software started accelerating before COVID. Companies were like, "Hey, we got to make more software, digitally transform our paper processes." And then COVID came, and that accelerated that because people rushed to digitally accelerate more and more of their stuff. People wanted to shop from home. Most grocery stores didn't even have an app. Everyone started to make things that offered their services digitally. So that accelerated it. And then now it's further accelerated with AI. So the rate at which people are putting out software is going up. But the practices have been manual. We're applying old school pen testing methodologies, but that's all about to change, right? As these AI tools come out, it's going to also help the AppSec people do things faster and at scale. I've been talking to a lot of our clients, and recently, a few of them are saying they're producing 300% more code than they were producing before. So they're like, "How do we scale our AppSec teams, Farshad? What do we do?" I said, "Well, you're gonna have to adopt AI tools with the right supervision, right? So you can't just like put these tools and hope they're doing the right thing." So there's still a place for that AppSec practitioner, but it's going to be more around how they harness the AI tools, how they fine tune them and deploy them in their environments and supervise them essentially to make sure they're doing the right thing.
That's good. Yeah, it's going to be a really interesting future. That's for sure.
Every day, man. Like it's like I wake up, one week is OpenClaw, another week is something else. Like, we as practitioners, we constantly have to keep on top of all this type of stuff, right? And it becomes a challenging proposition. We allocate 10% of our time for research and development just as a company, but that's something we need to probably do more of just to be on top of what's happening every day.
Yeah, it feels like I'm seeing more and more that AI is allowing you to do a lot, but it's also making you do a lot more. And so, I can feel that like the trajectory leads to a problem where the human is really not able to kind of like keep pace, and we kind of all tire ourselves out. So looking forward to see where that ends up.
Yeah, yes, yes. And I'm seeing some really good comments on the chat here as well. Yeah, Mark, I totally agree.
Yeah. Well, thanks a lot for coming in. That was super interesting. If folks want to get in touch with you, what's the best way to do that?
LinkedIn is the best way. Farshad Abasi, all over LinkedIn. Just to plug, I'm one of the organizers of B-Sides Vancouver, and that's happening May 31st, June 1st. So people should come to that if you want. I encourage all of you guys to submit a CFP and come do a talk or workshop. We just opened up the CFPs last week. So yeah, you can find me at B-Sides at OWASP Vancouver chapter. I'm there usually monthly. Our next one is February 19. And let me know on LinkedIn. I'm always happy to chat about these topics as well.
Awesome, awesome. Sounds good. Well, see you everybody for next Defender Friday next week. Bye.
Thanks for having me. This was great. Take care, everybody.